Hello everyone, welcome to today's video. In this video, we will be talking about SDLC models and we will be discussing the first model of the software development life cycle. So let us begin. We will be discussing about waterfall model today, which is one of the conventional and traditional approaches in which software development life cycle works. And to begin with waterfall model, it is a universally accepted model. So let us first write it down here as waterfall model, and it is a universally accepted SDLC model, and in this method the whole process of software development life cycle is divided into various phases, which we have already discussed in our previous video. So basically this waterfall model is a continuous software development model, which is in which development, design, so we will be focusing on design, development as well as deployment of the these three factors, these three D's basically are taken care of in this waterfall model in a different phase wise manner. So we have a linear ordering of the activities, which we have already discussed in our previous video. So we have linear ordering maintained in between the activities with some significant consequences. So first of all, there is a entry criteria and an exit criteria to each of the phases, entry as well as an exit criteria to each of the phases, and this entry or exit criteria will basically determine when a particular criteria or when a particular step ends and when does it begin. So let us first see how it looks like. The first step it begins with is the requirement analysis. So requirement analysis or the planning stage is the first step, followed by the design step. Once the design step is completed, we go ahead with the implementation or the development stage, and after the implementation is done, we have testing and system integration. So these steps we have already seen in our previous video. We will just be representing them in a waterfall model manner, and then we will be having the deployment, and finally we will be going ahead with the maintenance. So the initial 6 steps we have already discussed. So starting from requirement analysis, design, implementation or development, then we have testing, and then we have deployment, and finally we will be having this maintenance. Now what happens in this requirement analysis is that we basically develop a phase in which the customers input the market analysis surveys, as well as some senior members will be jotting down the requirements in a SRS document, and this SRS document will be passed on to the next phase, which is basically the design phase. In the design phase we will have a DDS document. So this DDS document will be having options of various designs related to the SRS, and the best one is chosen and is sent for the implementation. So based on this DDS document, the coding part is done, and once the coding part is done, it is tested both in granular as well as in as a whole, after integrating the granules or after integrating the different modules. And once this testing phase is completed, it is deployed in a phase wise manner or in a complete package, and finally it is maintained. Now this maintenance phase is a new phase which we will be discussing shortly, but before that, if you look into these steps, so what happens is the arrow here, it looks like that we are actually moving down across a waterfall. I mean, if we pour water from this point, so the water will basically move down in a fashion in which it looks like a waterfall, right? So hence it is known as a waterfall model. It will the steps basically resembles the different steps in a waterfall. Right now This is a very conventional and a traditional way of representing a software development life cycle, in which there we have no system no system of returning to the previous state. That means if I am having some error in the implementation stage, I cannot go back to the design, or I cannot go back to the implementation from the testing phase in order to correct it. Okay, so hence this conventional waterfall model is basically, though it is a widely accepted model, but a slight modification of this model is basically used in a practical scenario. So that is known as iterative waterfall model. So we'll also talk about iterative waterfall model, but first let us concentrate on the different components or different steps that this waterfall model has. So the first model is basically requirement analysis, and in this particular phase, the senior members of the team will actually jot down the various hardware and software requirements, as well as different types of other requirements which are associated with the project. They also take care of the cost, then the time of delivery, that means the economical aspect, the operational aspect, as well as the schedule aspect. So all these things are basically concentrated in requirement analysis, and a feasibility of the project is basically identified, that whether this particular project is feasible or not. So once this particular project is identified as feasible, it will be forwarded, this information which is recorded in the software requirement specification document, this is forwarded to the design phase. So in design phase, what happens is that based on this SRS, there are numerous designs which would be generated. So there might be one or two or maybe 4-5 designs for the same project. Okay, now out of those 4-5 designs, in the design document, the best possible design is chosen in an elected manner, or after analyzing it in a group or in a team. So the best design is chosen and it is sent forward for coding. That means in order to develop it in a real time. So the best design is documented in a design document, and this will be sent to the implementation stage directly, where coding will take place depending upon certain coding guidelines. And once these coding guidelines are over, once this guidelines are analyzed, a particular coding paradigm is selected, and based on that the development goes on. The development is supported with the testing phase, because as and when the development goes on in the modular level itself, you have to go on testing it. Okay, it is similar to writing a simple program. When we write a simple program, we simply, after writing a method or a function, we keep on compiling, right? So when that particular compilation is also a testing phase. So in projects also, software projects also, what happens after a module is developed, let's say module 1 is developed, it goes for a unit testing. So once this unit testing of all the modules are done, it will be integrated. So module 1, module 2, module 3, all those modules will be integrated, and an integration testing would be done. Okay, so once this integration testing is done, it is also tested against the system after it is incorporated in the real-time system. So that system, against that system also it is tested. So all the testing phase, it takes place in this particular phase, and after this it goes for deployment. Now deployment is that stage in which the actual implementation or actual deployment of the project with the customers is done. So it might be in a phase wise manner. That means, as already explained in my previous video, suppose I am developing a banking software, one by one the modules might be released for the customers use or for the users use, and once they receive a feedback, the final product is released. Or what they can do is, every time a new module is launched or a new module is developed, they can simply deploy it and go on adding it one by one, right? And finally there is a maintenance stage. Now this maintenance stage is basically in order to maintain that software. That means continuous upgradation of the software. If we need to incorporate any security to the existing software, okay, or if we have to incorporate any additional features to the existing software, So this comes under the maintenance. So maintenance can take care of the coding as well as the testing of new features as well. So all this stage basically comprises of the standard waterfall model. Now what will happen if there is some problem in the design phase itself and we have already proceeded with the implementation? So we cannot go back to the design stage in the traditional cascading waterfall model. Okay, so what we have to do is we have to formulate a mechanism in which we can go back to the previous stage. So for that, a modification of this model, which is known as iterative waterfall model, was introduced. What is the benefit of this iterative waterfall model? That from each of the stages, let me first draw it. From each of the stages there is a loop, or we can actually go back to the previous step. So from each of the stages we can go back to the previous stage, right? So either we can represent in this manner, or it will be easier if we can show it. Let's say I will just erase this and we will show it in a different manner. Okay, so from each of the stages I can go back to the previous stage. So what happens here is that if there is a problem in my previous stage, I can go back to the previous stage and I can get it corrected then and there. Okay, so that if there is any error in the testing phase, even though I have deployed it, I can go back to the testing phase, as well as from the testing phase I can go back to the implementation stage in order to change the required implementation and finally follow the correct procedure. Now this is basically all about waterfall model and also about iterative waterfall model, where we can actually go back to the previous stage if at all anything is needed. Now the question here arises is of what do we mean by this particular entry and exit criteria. Now this entry and exit criteria is associated with each of these stages. Okay, entry in each of these stages. That means the exit criteria for implementation stage would be the entry criteria for the testing phase. That means once we have met, these criteria are introduced for each of these phases, so that once the exit criteria of one phase is met, we also identify that as the entry criteria for the next stage. That means the exit criteria for requirement analysis will be the SRS document, and once the SRS document has been completed, it will enter into the next phase. So we have the entry and exit criteria of each of the stages whenever we are working with it. Okay, now this is one of the classical models of waterfall model, and it comes with a lot of advantages and disadvantages. So if we talk about the advantages of the classical waterfall model or the iterative waterfall model, so what are its advantages? So it is a very simple and linear. It is linear and simple to understand. Simple to understand. And it has very clearly defined entry and exit criteria. Entry and exit criteria. However, one major problem with this particular waterfall model is that it will not take care of the risks involved. Okay, so in order to introduce the risk module, we have to follow some other model, but the minimum amount of checks is already present. Okay, so that we do not have to bother much, but we also have to concentrate some of the other aspects which are related to the waterfall model. That means because the model is very rigid, that means it will have those 6 number of steps. Okay, so this clearly defined review process or clearly define entry and exit criteria helps it to become more manageable. Okay, and these phases are processed and completed one at a time. Okay, overlapping of phases is not there, and it works best for small projects. So if we have a small project like the mini project, major project in your courses, okay, so we can go ahead with this type of projects, I mean this type of models. Okay, so it works best for small projects where the requirements are clearly understood and they are defined well. So in our mini projects we have very limited requirements, so those can be well understood and well in advance, so we can use this particular waterfall model for developing it. Now what are the disadvantages? It comes with a number of disadvantages due to which some other models needs to be used. So once an application is in the testing stage, it is very difficult to go back and change something that was not well thought out in the concept stage. So for moving between stages, it becomes challenging. Okay, so it becomes challenging if we want to go back to some stage. Okay, we have to follow a long route, that means go back one stage at a time. We cannot simply jump to that particular stage. Okay, and there is no working prototype or there is no working software is produced during the life cycle. Only until late, after all the steps, at least 5 steps are completed, we get a product. Okay, software is produced until late during life cycle. We have to wait until the deployment is done, then only we will get a particular working software. Okay, during the life cycle. The third, as already discussed, high risk. Since risk analysis is not done here, high risk is involved. Then it's a very poor model, or it's a poor model for large and ongoing projects. And not suitable for projects where the requirements are at a moderate or high risk of changing. So if we go on, if the customer goes on changing the requirements later, okay, sometimes at the last moment the customer wants a change, then we will not be able to use this particular model. So we have discussed about the waterfall model, and we have also seen what are the advantages and disadvantages associated with this particular model. So in order to curb the disadvantages and introduce more advantages to the software development life cycle, some other models were also developed, which we will be talking about in my next video. So that is all from classical waterfall model, as well as we also discussed some parts of the iterative waterfall model. Thank you.